Awesome. Hey guys, thanks everyone. Looks like we have a lot of folks joining and still joining in. Really appreciate you guys joining this educational webinar on how artificial intelligence is being used in logistics today. Where are some of the opportunities that we've seen around automation in the back office? And then something new that we're seeing, a very big trend within the industry, which is finding capacity using AI. And just to get started, I'm going to just give a quick introduction on who we are. So my name is Param Sandhu. I am the co-founder and CEO of LoadTap. And Lakshmi, who is also on, he's the co-founder and CTO of LoadTap. And at LoadTap, we use AI technologies to help automate logistics. And you can find out more on our website down there at loadtap.com. So just to give you guys a quick agenda, we'll go over what is AI. We'll give you some very basic examples. AI is being used today in our everyday lives. We'll show you where those opportunities and those use cases are. And then we'll quickly go over how AI systems work. We'll keep it high level. We don't want to make it too technical. And then get to the juicy stuff, which is the applications in logistics. How do we use AI? How does it help automate a lot of the operations and really drive more volume for logistics providers and more revenue, and also reduce the cost to serve? And then in the end, we'll have a Q&A. There is a chat where you can type questions that we'll get to in the end. So we already have a handful of questions as well. So if you guys have questions, please feel free to send those out. And just to give a quick overview on AI, it'll be Lakshmi that'll be taking over.
Hello, everyone. This is Lakshmi here. I'll start with a very simple and a quick definition of AI. All this started with a very simple question. Can a machine think and behave like humans? According to father of artificial intelligence, John McCarthy, AI is the science and engineering of making intelligent machines, especially intelligent computer programs. I like this very simple description of AI. AI is creating the computers or machines as intelligent as human beings. To get into a little bit more detailed definition over here, artificial intelligence can be defined as human intelligence exhibited by machines. Systems that approximate, mimic, replicate, automate, and eventually improve on human thinking. So there are few components of AI, like perceive, perception, understanding, learn like humans, solve a problem, and reasoning.
So Lakshmi, let me just interject here. So what I perceive this as is when we're looking at AI, my understanding here is that we're trying to mimic human behavior. So what is, can you give us an example of how these systems work from, what type of data input we need? And I know we're going to get into some logistics examples in a second, but if you have any examples in terms of data.
Yes, exactly. So, when initially the research started on AI, the initial scientists, what they did, they just studied human beings, right? How the human beings learn, how do they make decisions. So the one thing was one thing they learned how the human beings learn. They learn from examples, they learn from data, and then they recognize some patterns. Based on those patterns, in any new situations, they make decisions. All the AI systems are built exactly on that philosophy.
Excellent, excellent.
So yes, so there basically are three components: learn, get the data, learn from it, and then make decisions. So when we build an AI systems, it has very specific. Any AI system would have specific steps. All the AI system would work in this way. All the AI system would need data. Any AI system needs data. It's called training data. data could be in any format like text file, images, sound, machine, based on what system you're developing. This data is gathered continuously from different sources, and any system first would process this data and create into a format or a structured data that that AI system would understand. Then this data is processed through machine learning frameworks. There are a lot of machine learning frameworks out there, and open source is doing a great job of building new system on daily basis. The the machine learning frameworks try to identify the patterns and trends in the data and build a model. Once the model is ready, your system is ready, we input data and it can make decisions. And this process is not a one-time process, it's a continuous process. Based on your system, this process could be done, repeated on daily basis, it could be repeated on weekly basis, it could be repeated on monthly basis. It depends on how frequently your data changes, how frequently you get your data input. So if I have to make it simpler, there are 3 phases. We can call it sensing, processing, and learning. In the sensing phase, you collect data. In the processing phase, we normally convert the data into the format that is understood by our system. And in learning phase, the data is fed through the AI system, where we recognize the patterns and trends in the data. And after that, this model is built in the learning phase, is used to make any decisions for a given system.
One of the things that I just want to highlight here for a lot of the listeners is, with any AI technology, whether we're using it in logistics, whether we're using it in anywhere else, there is a constant feed of training data that is always added to the model, and it constantly trains the model. So over time, it does improve. It does get better as we're seeing new types of data coming in, and whether it's in logistics, if we're seeing new types of ways that shipping orders are sent from customers. The beauty of any AI or machine learning system is that it will learn, and it'll learn all the new different methods that it's seeing, or new different data inputs that it's seeing. So maybe we'll jump into just a couple of real world examples, and then right after that, we'll go right into the logistics portion of it.
Yes. So I think there are a lot of examples right now out there. Sometimes we may not even know that AIs are used in backend. Most common are Amazon Alexa, Google Assistant, Apple Siri, and Microsoft Cortana. So let's give an example of Apple Siri. She is the friendly voice-activated computer that we interact with on a daily basis. She can help us find information, can give us direction, and tells about the events. How does that work? Siri can get data input from different formats. It can read our email, it can understand our voice, and it gets better as we speak more with Siri. It learns on daily basis our pattern, and can understand our voice, and can become more intelligent, specific to the person it's talking to on daily basis. So, yeah, Param, next.
Let me just add one thing here. So one of the beauty of what we're seeing with a lot of these systems as well is they are becoming smarter, right? So these advances in speech to text technology now are significantly enabling voice-driven AI. So just to kind of give you an example, I mean, today the comprehension ability of these AI-driven voice assistants like Alexa, like Google, like Siri, they're actually surpassing that of humans. And there's an interesting statistic that I saw the other day that if you look at a typical interaction between two people, or two people that are having a conversation, the average percentage of words that are misunderstood by each person is around 6%. And today, the best AI-driven voice assistants are able to achieve a word error rate of 5%. It is a 1% increase, but essentially, these systems are learning over time and they are improving, and we've come a long way from even 5 years ago.
Exactly. So one very common example is Netflix. So Netflix collects the data based on what movies you watch, how long you watch the movie, at what time of the day you watch the movie. That's the input data, and it learns, compares that data with other people, and find a trends, patterns, and then make a recommendation what movies you would most likely like to watch at that particular time of the day.
So now we'll jump right into the AI applications in logistics. Some of the applications that we're seeing today, and some of the ones that are not too far off in the future as well. And just before we get started on that, one of the big key things in being able to leverage AI system is harnessing the data, right? I mean, the most clear use case for AI in logistics is being able to harness all the data from many different systems, whether it's your TMS, whether it's data you have within your emails, analyzing that data, and then being able to identify and provide insight and patterns to help make better decisions for your employees. And so data that is used to power automation, to identify those patterns. And then the AI isn't something that is replacing the workers. It is something that is empowering the workers. I think there's a big misunderstanding when the term AI or machine learning gets referenced. And people start to think that, hey, this is going to replace the workers. It actually makes the workers smarter. It makes our employees smarter, faster. They're able to make decisions that are, less with errors in them. There was a report done by DHL and IBM that stated that one of the most underutilized assets in the logistics industry is the high volume of data that is generated on a daily basis. This data is both structured, as in cleaned up, put into your TMS, or it is unstructured. It's in the form of emails that are sent out or fax machines that are sent out that people are now inputting into the TMS. And what AI will enable us to do is really help logistics companies exploit that. And so we'll come into a very common example that we've seen in a lot of the top 3PLs, the top freight brokerages, is a back office automation, and specifically related to customer orders. If you look at how customer orders are sent today, they're sent in many different formats in many different ways. As a logistics provider, you want to service your customer. You want to be open to any method that they send you, whether it's email, whether it is sending via fax, whether it's telling you the order on the phone, or SMS. And so what happens is now we see hundreds of formats of emails, all for different customers. With AI, this process can be automated. So what AI and machine learning can do is it can be used to identify and parse all of the data that is needed to build a load tender. It can recognize different formats. It can identify which fields correspond to a pickup address, which fields correspond to a delivery address, how to parse out the rate, and how do I enter it automatically in the TMS in a usable format. And one of the beauties of AI and machine learning is the system gets smarter over time with more data. And I think Lakshmi showed that in a previous slide, where you're constantly putting in training data. And what this does is it allows the system or the AI to be very specific. For example, let's say Bob's Furniture. They're always sending a new order via email. They have a very specific format. And what now the AI system can do is it can learn Bob's Furniture's order behavior. And if Bob's Furniture is always missing dimensions on the order, well, now what the system can do is automatically send out an email to Bob every time they receive an order recognize that it doesn't have the dimensions of the shipment that needs to be shipped out, and then request that automatically. So just some of the ways that from the back office side, AI can be leveraged into something simple like putting in customer orders right inside your TMS. And another example that Lakshmi and I have spoken about in great detail is using a lot of these voice assistants, but integrating them into your logistics operation. And I have a very specific example. And let's say we use Alexa for doing shipment tracking. And so another great use case with that would be is plug in Alexa right into your TMS and be able to retrieve information. And to demonstrate this, it's as simple as asking, hey Siri or hey Cortana, what is the status of PO number 4958? And since the data is already within your TMS, this information will automatically be retrieved. She'll just go back and say, well, the status is the driver was loaded and the current location is Dallas, Texas. Well, you can take this one step further. Not only can these voice assistants be used to retrieve information, we can also give them commands. And we can now say that, okay, we've gotten the update for a specific PO number. Now, how do we send that to the customer? Well, I can just say, hey, Siri, send an update email to customer for PO number 4958. And just like that, it's already coded in the background, and the email will get sent right to your customer. And it doesn't have to stop there. You can actually make it even more complex than receiving information and giving orders. You can actually automate this. So one of the ways to completely automate this process would be having an AI system recognize that, hey, certain customers require updates at specific times. Customer A always wants them 3 times a day. Customer B always wants them at pickup and delivery. And what you can do is have the AI actually recognize customer behavior and then automatically provide these updates to the customer. And if the update isn't available, let's say for a specific shipment, well, what the system can do is actually message your team and ask for an update, or actually message a carrier or dispatcher via email, via automatic phone call, and retrieve this update and forward it to your customer automatically. And Alexa and Siri and all of these voice assistants, they have third-party APIs that you can plug into and really start playing around with retrieving information from your TMS and sending commands. And so another use case that we wanted to highlight today, it's a use case around finding capacity. How can we leverage artificial intelligence, machine learning, and the vast amount of data that we have within our TMS or in our location tracking systems, and use that to find capacity faster. Everybody's complaining today about how capacity is extremely tight. It's getting harder to find trucks. The speed to find a truck is driving the market to become faster and faster. And a lot of the large companies have recognized this. The C.H. Robinsons, a lot of the new incumbents, the Uber Freights, they've recognized that being able to find capacity faster and at a reasonable rate is what's really driving their business today. And so we'll show you how some of this is done. And so there's 2 ways that we can use data to find capacity. One way is looking at the historical data we have inside of our TMSs already. In our TMSs, we have a lot of data like historical data on carriers, what the carrier's preferences are. What we can do with all of that data is now look at all the current loads that the carriers are on, start analyzing the margins on specific lanes or specific markets. For example, hey, I'm making more margins from Dallas to Atlanta than I am from New York to Florida. That actually might be a bad example because New York to Florida is a great market for brokers. But what we can do is start analyzing this data and say, hey, in the last 3 days, the New York market, we've been making killer margins on. And capacity, and we're able to find capacity a lot quicker and correlate those margins with a better capacity, and looking at historical rates as well. And now provide that information to your sales team. Hey, New York is a hot market right now. We're finding capacity quicker. Let's go pound the phones and find customers that are shipping out of New York. Just an example there. Pricing is another great example. We can look at a lot of third-party sources and build together a pricing algorithm. How can we use data that's pulled from DAT, data that's pulled from diesel prices, and link that to any data you have in your internal system based off specific markets or specific lanes? And how can we come up with better pricing? How can we have pricing suggestions being made to us? A lot of the things that are done by 3PLs and brokers is getting quotes and inputting those within the TMS. Now, as we're getting quotes on a daily basis, how can we leverage that quote data as well to make sure that we're getting the best price and squeezing our margins? So these are some of the things that are actually we're seeing today. We're seeing some TMS providers do it. We're seeing some third-party people do it as well. And definitely from the carrier qualification portion, where this is one of the more common use cases, is being able to look at all the historical data that's present and help identify where the best carriers are to use for specific freight. Historical data can tell us a lot. Where do carriers have capacity, in what regions, on what days? Hey, Joe's Trucking is always present on Monday and Tuesdays in Dallas. Let me prioritize him for all Dallas freight that's shipping out on Monday and Tuesdays. So some of this we see today with historical data. The next evolution of this, how do we now take this to the next level, is now how do we use real-time data within a TMS? And once you start getting real-time data, and one example would be real-time location data, right? We are seeing a lot of different track and trace technologies. ELDs are now penetrating the market. Historically, small trucking companies did not have ELDs in them. Now we're seeing ELDs across the board. And now how do we leverage this data within ELDs, within whatever track and trace provider you're using? And how do we use that to now help with capacity matching, right? It's a trend we're seeing heavily in the industry today. A lot of companies are now investing in this notion of predictive capacity, and this notion of, let me use real-time data to find capacity. We say predictive because when we look at location data, whether it's from ELDs, whether it's from your track and trace, that data is not enough to help you with identifying if this is the correct capacity for any freight that you have available. You may know that, hey, a truck is in New Mexico, but you have no idea if that truck is on a current shipment, if it's at a backhaul, if it's at a midpoint. So really, you have to start predicting the capacity and leverage historical data, real-time data, and find out, when is the carrier going to be at either a forward haul or a backhaul? And I'll show you an example of how some of the things that we've seen today, also you were doing at LoadTap as well, of being able to leverage location data and now start predicting where are trucks going to be and where do they want to go. And being able to do this 3, 4, 5, and maybe a week in advance as well. And also using the location data, now that we see trucks that are being tracked, capacity that's being tracked, how do we qualify a specific carrier down to the truck level, down to the driver level, and how do we qualify them in their preferences? So I have a great example for this. I'll show you with some real-time data, but just a quick reference is how do we know down to the driver level what lanes they prefer? A lot of you folks listening, if you're onboarding carriers, you have a carrier packet that you sent out, and in the carrier packet you have lane preferences. What we've seen is a lot of times carriers will put lane preferences, but there's always additional lanes that they're running that they may not have specified, or they say they run everything, which is usually not the case. And it's what we've identified. It comes down to either the individual unit or down to the driver level. But now with location data, you can actually qualify this using an AI system. You don't need to now ask for this information. You can auto qualify the carrier. And I have some visual examples in a second. And what you can now start doing is with this predictive capacity, now you know where the truck's going to be days in advance and in what regions, right? And now you know that regions and specific markets that will have excess capacity. This data is excellent for your sales teams. You know that, Dallas to Atlanta on next Monday, you're going to have 200 additional trucks than you usually use based off the real-time location. Now what you can do is now start having your sales team pound the phones, find out as much Dallas outbound for Monday, and also being able to now identify those carriers that will be there in advance, book the freight ahead of time, and really try to drive your margins up. And so one of the examples I was talking about is predictive capacity matching. How do you use predictive analytics? How do you use machine learning? So one of the things you can start doing is now leverage this predictive capacity matching with the artificial intelligence to help teams, help CSRs, carrier sales reps, or freight brokers get better suggestions on carriers. Now we're looking beyond just historical information. We're looking beyond just, hey, I know all the carriers that have done Los Angeles to Dallas. Let me call them one by one. We can take this one step further and now say, hey, here are the 5 carriers that run Los Angeles to Dallas. They run a 53-foot dry van. They're within the margins of what I'm trying to run at. And they're going to be in the area on the day that this shipment needs to be picked up. And now you're reducing, mass emails, you're reducing, 15, 20 phone calls down to 2 phone calls, down to 3 phone calls, and being able to quickly find that capacity a lot faster rather than just, shooting arrows in the dark and calling carriers that you think may have capacity as well. And the beauty of a AI system to help assist your carrier sales reps, to help assist your freight brokers, is if there's patterns that are associated with certain carriers. For example, CSR may know, hey, I know, U.S. trucking always has capacity in Los Angeles. Well, that information can also get built into the model that, hey, if this specific carrier has capacity on a certain day, we can make those recommendations. And now we can also couple that with the real-time location piece as well. So here's an example. I was talking about lane analysis, all right? And coming back to the example of carrier packets, right? Carriers are putting in, and I'll use this live data here as an example. Let's say the carrier in the carrier packet says, I run Florida to Texas, and I run Florida to Georgia. Well, in your TMS today, you have this carrier tendered for a South Florida, and they drive up to San Antonio, Texas. Well, what happens after San Antonio, Texas? Let's say the load is delivered here. Based off this heat map, we see that the driver was stopped here for quite a bit of time and delivered there. But after San Antonio, Texas, they pick up freight in San Antonio, and then they now travel over to Phoenix down to Southern California. That's a new lane that's identified. So what these smart AI systems can do is now not only qualify this carrier for South Florida to San Antonio, now we have San Antonio to SoCal, then SoCal to Oklahoma City, and down all the way to Atlanta. So now we're identifying new lanes for this carrier. And now what smart systems can do is predict where that specific capacity is going to end up at. Now, if this truck is traveling on the freeway out of South Florida, there's a probability now associated with, hey, there's an 80% chance it's going to be in San Antonio 2 days from now. There's a 90% chance it'll be in Southern California 5 days from now. And now we can use this predictability and this data to really help with matching freight with capacity in the future. This is where we're seeing the industry headed. We're seeing this in a lot of different organizations as well. This is some of the things that LoadTap is actively working on. We have customers with this as well. And really, it's being able to now leverage this beautiful real-time data that we finally have access for capacity matching. And you can take it one step further, right? You can even micro qualify a carrier. And this is what I was referring to in driver preferences. If you have specific drivers, specific carriers, and I like to use San Francisco as an example because we see it very commonly here. But a lot of trucks, they don't like to pick up in San Francisco. They'll pick up on the other side of the bridge in Oakland. They'll pick up further towards Sacramento, which is all within a 100-mile radius of Sacramento. But they will not go to San Francisco because it's just very, very difficult for drivers to drive there. But there are very few carriers that will. So what you can do now is micro qualify a carrier down to the driver preference. Now, instead of looking at, hey, show me all the trucks that will pick up within a 100-mile radius of San Francisco, we can leverage this historical data. And now we can look at, hey, show me the carriers that will pick up in San Francisco, that have picked up in San Francisco, and being able to actually qualify first the carriers that have historically been to San Francisco and not just in a mile radius. And so being able to now get down to the driver preferences, down to which freeways they like to run. Some drivers prefer the 40 over the I-10 if they're going to Texas. Being able to look at those patterns and really leverage that for matching with freight and being able to qualify capacity. And these are just some of the things we're seeing, the value that we're seeing, and how this is adding. What is the value that'll happen to the logistics providers, the 3PLs? It's more qualified match suggestions. This isn't automatically doing freight and capacity matching. This is only suggesting matches, right? It really is empowering CSRs, empowering freight brokers to reduce the time to find a truck. It allows operation teams to find capacity faster, right? And right now, the industry average we're seeing is about 8 to 10 full truckloads per CSR, per freight broker. Now, how do we increase that to 10 to 15? How do we get to the next phase of the full truckloads that each individual person can manage? And to do that, we have to have ways to make faster decisions. And then finally, lane analytics, like we talked about, the value is helping sales team go pound the phones for lanes where they know there's going to be excess capacity on certain days. So just some of the trends that we're seeing here today. So I have been seeing a lot of questions popping up here. If you guys have any questions, keep asking them. I think we're just about ready to go into the Q&A section. But just before we do that, I want to just share on where this industry is headed. I want to look ahead. This industry is ready for AI. It's actually being used today. We're seeing it more and more. And as you'll see in the next year or so, there's going to be a huge focus on AI and machine learning and how it can help operations be faster. There's a lot of new incumbents like Uber Freight and some of the Uber for trucking startups that are using this. But the older incumbents like C.H. Robinson's have been investing heavily into these technologies because automation is the key to automation using AI is the key to reduce your cost to serve. How do you reduce the cost to serve? How do you make better and faster decisions in a market that is now relying ever more on speed? How do you find trucks faster? How do you do more volume per employee, per CSR, per freight broker? And so with that, we'll get right to the questions. If you guys have anything additional, if you want to learn more about LoadTap, feel free to email one of us. But we'll keep this focused on some of the questions that you guys have. And so let me just open this up 1 second. And so the first question we have here is, and Lakshmi, this might be a question for you. How much data does your AI system require to be effective?
It depends on how the system is developed. For us, I think 2 weeks of data, minimum 2 weeks of data is good enough. More data we have, the system gets better.
Okay, so typically around 2 weeks, and you'll start being able to have some value driven with that?
We can start seeing the value with just 2 weeks worth of data.
Okay. I think the next one will also be for you. What is the type of data required for for capacity systems? I'm assuming that's the capacity matching that was asked.
Okay, so basically, if we can get all the historical loads done with the information of the carriers who have done what they pickups, drops, the time, that should be good enough.
Okay. And is that something that is just obtained from the integration with the TMS, or do users have to manually input this?
No, this could be pulled out of their TMS and can be given in an Excel sheet or a text file.
Okay.
And we can feed that data into our system.
We have one question here. I am somewhat confused by the track and trace feature that stands out on your website versus the truck sourcing feature. I'm specifically interested in fast, more efficient ways to find trucks, as we are a non-asset broker. Does this system find trucks faster, or is it just a track and trace track and trace feature? I can answer this one. And this is, I think it's related to what one of the attendees has seen on our website. We have a track and trace feature. We have also capacity matching and capacity finding feature. We actually connect both of them. The track and trace brings in the location portion of it. I talked a lot about, how location can be leveraged. Track and trace is done through mobile app. It's done through ELDs integrations. It's done through appless models as well. And then we use a lot of that track and trace data. We qualify the carriers, and we use that for the capacity matching component of it. I have another question. This was emailed from me. This is from Phil at Tandem Logistics. Is LoadTap a standalone platform, or must an API be established? And if API, can you provide the names of the TMSs that you have established APIs with? So LoadTap, as I mentioned, we have two offerings. We have the track and trace. That can be standalone, or that can be through TMS integrations. For our capacity matching, we do require integration into a TMS. And the TMSs that we're integrated into today, or are actively working on integrations, are MercuryGate, 3G TMS, Revenova, and then we have a lot of proprietary TMSs and homegrown TMSs that we integrate through APIs with as well. We can do XML, FTP, and then Oracle. Oracle is another one that is also there as well. So we have a handful of them. If there's one of those TMSs you don't have, and this is something that is, what you see tremendous value to your business, we'll go ahead and integrate with that TMS. And that's just how we've been doing it. Anytime we have a new customer with a new TMS, we end up integrating with that TMS. And then just Phil with the follow-up for McLeod. McLeod is in the pipeline, Phil. That is one that we're looking at hopefully early of next year. But it really depends on the the demand there. We have had a handful of people requesting that. Let me just open this up. I have a few more popping up here. Here we go. So this is from Rob. As a third party, we do not have access to driver phones or ELDs. How would we populate this data without these tools? That's a great question, Rob. Typically, there's a handful of ways to be able to get this from the capacity component. Even without the real-time location, our AI is able to look at all your historical data and make those suggestions. But what we'll do is we'll look at your top carriers, who are the most frequently used carriers, and then we'll actually plug them onboard them one by one through their ELD provider. Since we're integrated with a lot of different ELDs, we'll actually plug in that capacity. It'll be almost a private network just for you. And if you don't have access to drivers' phones, the ELDs would probably be the best way for us to do this. And some of the ways we've done this, I'll give an example. One of our customers, about 20% of their carriers, they reuse on a regular basis. We compiled that list of carriers. We went through all of them one by one, and we plugged them in through their ELD, since we already have the ELD integrations in place. We also have our track and trace technology as well that can assist in getting this. If you're not getting driver phones, ELD would be the way, but if you are getting driver phones as well, we would allow you to leverage our track and trace. Let's see. Do you have any current data that shows how efficient or accurate this can be? We do have data, there is a case study that we will be publishing very soon. What we'll do is we'll send out that case study to all the attendees here. In the next 2 weeks or so, it'll be a case study on about 5 customers that have been using this actively. And that way you'll see the value. But some of the early numbers that we're seeing is 40 to 50% increase in the number of truckloads that are matched, that are managed per CSR. We're also seeing an increase in carrier engagement as well, where it's a little more sticky to the carrier. So we'll share some of those. So I have another question here. This is a pricing related question. I prefer not to get too much into pricing. If this pricing is if it's more of an interest, I'd love to have that conversation separately. Just shoot me an email. And then I have, what is the average time frame and cost to bring this program up to speed? The cost we can discuss separately, and this is from Rob. Rob, I'll be happy to just shoot you a note on pricing separately. In terms of time frame, Lakshmi, do you mind just sharing a little bit of how fast we've been able to onboard customers and TMSs?
I think it takes somewhere around 2 weeks to get started, and I've seen the customer seeing value in within 1 to 2 months.
Awesome, awesome. So I hope that answers your question there, Rob. Let's see. So Tim, it looks like Tim said someone will have to contact the driver or dispatcher to update our TMS before AI could send out an update to the customer. Tim, that's a great question. There's 2 ways that this can be done, right? If you're not using anything, any track and trace product, yes, you will have to contact the driver, but you can also send notifications out to the driver or dispatcher with the AI system. So the AI system can recognize that there's no update from this driver, there's no update from this dispatcher. Let me send an email automatically to the dispatcher. Let me send an SMS automatically to the driver to request an update, pull that information in, and then send that to the customer. Another way, and this is the way that we're seeing the industry evolve and what we're pushing for here at LoTap, is through track and trace. We make sure that you're tracking majority of your freight in real time using different technologies, whether it's cell tower where the driver responds yes to a text message, whether it's through ELD. That information will constantly get populated automatically into the TMS. And so for those cases, the updates are sent completely automatic to the customer without somebody having to contact a driver or dispatcher. Awesome. And I think that's most of the questions I have. If I see any other question that pop up, I'll try to address it, but our contact information is here. Paramveer@lotap.com for myself, Lakshmi.at.lotap.com. Feel free to reach out to us if there's any questions. We will provide you a copy of this video as well, since it was recorded. But other than that, guys, hey, thank you guys so much for attending. Really appreciate you guys. We had a great turnout today, and we look forward to doing more of these sessions on different topics in the future. Thank you, guys.
Yeah, thank you, guys.